Today I'm going to demonstrate how Hawkeye can assist in a scenario with a load balancer and some backing services. But first, a few words on Hawkeye. It's here to help your team that's fighting an uphill battle, if you will, where the more visibility they get, the less clarity because you have so much complexity in your environment, so many metrics, alerts, complex systems, and it's very hard to keep up, right? And to make this more complicated, you have a diverse set of tools that you have to leverage in order to solve these problems. So rarely do you have all the information all in one place in order to analyze root cause. And so this is where Hawkeye comes in. Hawkeye basically sits in the middle in between your incident management, so it's an incident response agent, and then is able to read your config from your cloud sources, look at your logs, metrics, and traces, and leverage LLMs for reasoning about the root cause of your issue. So you can actually coach Hawkeye with instructions, things like standard operating procedures, runbooks, and architecture docs. And then your SREs come in and review Hawkeye analyses and provide follow-up questions and perhaps also use it as a co-pilot and prompt it. So let's look at a scenario and then we're going to demonstrate how we solve that scenario. In this scenario, we're going to see how a code change being pushed by GitHub Actions to our Stay Finder Hotel application front end updates only one of the two servers with a new port information that is also then configured on the Stay Finder backend. So the StayFinder front end node without the code change will start failing, and we'll see that show up in our client that's using curl hitting our application load balancer. So all of these components, including the GitHub Actions worker node, are logging to CloudWatch, and we're going to see how Hawkeye will be able to leverage the CloudWatch logs and metrics in order to analyze this issue and provide a root cause explanation. So let's look at our setup in the Amazon Web Console. So we see here our StayFinder application load balancer, and we'll see the application load balancer as our two target groups. And if we go and look at our EC2 instances, we're going to see the application front end and back end. So we see two StayFinder front end nodes as well as the StayFinder back end node. So now let's go look at our client. We're using curl and hitting our application load balancer, and we're seeing just good responses, 200s. And if we curl the data endpoint directly, we're going to see the returned data from our StayFinder application, a list of hotels. We're going to next look at the code. It's a Flask application that's simply returning a hard-coded list of hotels, and it's deployed as a service on the EC2 instance with this port. And our NGINX proxy is pointing at that instance of the backend on port 5000. So I'm going to change the port to 6000 here on the service as well as on the NGINX configuration. And then we're going to see how the deployment is going to only update one of the nodes. So let's check our code in and deploy it. Our GitHub action has two steps. The deploy front end step, as you'll see here, is going to skip the one of the two nodes causing the failure. And here we see our curl commands failing one out of every two requests because one of our front end servers is misconfigured. This in turn has caused this alert, HTTP code target 5xx count, to trigger on our application load balancer. And you'll see it show up here in our Hawkeye project summary view with all the open and resolved alerts. Here you can actually trigger investigations manually or consult the ones that were automatically investigated. And we're going to look at the summary for this investigation. And when we select the view summary, it will take us to that root cause analysis. So the first thing you'll see is the summary, the session summary, providing a summary of the root cause analysis. So you see here the partially failed NGINX configuration deployment resulted in one front-end host, and it specifies which host, maintaining outdated port settings, causing 502 bad gateway errors on the client. So very quickly, the SRE can understand what is happening without having to go anywhere, look at any data, and then can read the rest of the incident description, timeline of events, the evidence, as well as the root cause. The root cause was a partially successful NGINX configuration deployment where one front-end host was skipped during the update. This host continued to use old port settings when attempting to connect to the upstream service, resulting in connection refusals and subsequent 502 errors. Corrective actions. So go to the node and change the config for NGINX and restart. Verify configuration consistency across the hosts. Implement configuration validation in GitHub Action workflow, and add some additional monitoring here. Now, you might want to know how this root cause was created. And so you can actually look at the full analysis here and consult the chain of thought that was leveraged to arrive at this conclusion. So a chain of thought is a series of questions with associated data sources, metrics, and logs that were used to answer the questions. Hawkeye creates application programs that will go access these data sources and provide the facts back to the LLMs for reasoning only. So we don't just send all the logs to the LLM, we process the logs outside of the LLM using code generated by the LLM. And so you have a very detailed analysis here available to the user who's maybe curious as to why the conclusion was drawn. And so you'll see, the different logs that were used, the front end logs, and then eventually the security groups on the load balancer, network interface, VPCs. A lot of data was consulted in order to arrive at this conclusion. And then the user digging a little further came in and asked the follow-up question. And we'll see in this follow-up questions, the NGINX configuration changes were narrowed down to the deployment with the GitHub Actions. So we see here the GitHub Action runner logs were consulted. Now let's take a quick look at the logs. So you see here in CloudWatch, you have our log groups, and you see the GitHub logs that were used by Hawkeye to determine that the node got skipped. So you'll see here the copied config file to host, and then another message saying skipping deploying nginx config changes to host. The other logs that were used were the access logs for the front end. So you'll see two log streams here, one for each server. One of them has our 502s, and the other is showing the 200s. And finally, the error logs show all the errors related to this failing connection. So this is all the information that Hawkeye really needed in order to understand why the failure was occurring and identifying the
port as being the root cause.